I think we're ready. Everybody, welcome. The title of this talk is Everything is Agent, and I'm very, very excited about this. This is going to be a bit technical, but I know we have a pretty wide audience, so I'm going to try to explain at multiple levels over here. But the background here is probably for the past year or so, I have been intentionally trying to really push LLMs and agents to the limits, and there are absolutely limits. And in the process, I think I've been absolutely blown away. And I would just wanted to have a conversation with the group over here around some of the things that I've learned, some of the sort of mental models that I have, techniques that we can use to get these things to actually do effective work for us, and maybe a more nuanced understanding of what they're capable of and not really capable of. And so with that in mind, the first idea here is that I genuinely believe that agents specifically, so as distinct from AI in general, LLM-driven agents, which I'll get to what this actually means in a second formally, I believe that agents are going to be the primary driver of outsized economic growth over the next decade. And so a lot of the efficiencies that we'll see in terms of GDP in the aggregate, or just value delivered at the level of companies or at the level of individuals, I believe is going to be driven as a result of agents. And I think one of the key metrics that we're going to notice is just this ratio of humans to agents. And so over time, as our ability to sort of manage these agents increases, I think we'll be able to deploy more and more of them to get useful work done. And this ratio, I think, is just going to grow over time. And so one, I think, clear way to start this journey is to really juxtapose biological thinking and digital thinking, because I think that they're very, very different. And really, we have like one word and this sort of anthropomorphic tendency to kind of think about digital thinking as human thinking, but I think they're very, very different. And so let's sort of contrast them. First and foremost, biological thinking is very, very slow, and it's single-threaded. Really, I can only think of one thing at a time in sequence, and very many times I can't even control what I'm thinking, meaning I can't really decide whether I can be focused. It just sort of happens. On the other hand, digital thinking, like LLM use, agentic use, however you want to call it, is very, very parallelizable. So I can run multiple of these agents in parallel without really a clear upper limit. And relatively speaking, they're extremely fast. So the rate of token generation or the rate of thinking, I guess you could say, is just much faster than biological thinking. On the biological side, obviously, thinking as humans is very expensive. If you just think about the hourly salaries or annual salaries that we have, or even just like the opportunity cost of us spending time thinking about something, it's extremely expensive. Comparatively, digital thinking is much, much cheaper on a per token basis. But then obviously biological thinking has many advantages as well. The most important one of which I think is this notion of longitudinal memory. We as humans learn from experience. We remember what we did. We remember the mistakes we made and what worked and what didn't work. And we carry that learning into the actions of like our next actions and have that sort of shape how we approach tasks every day and every month and every year and so on, right? And comparatively, these agents don't have any memory. Every single agent run is fundamentally stateless. I guess you could argue whether the sort of weights of the model are updating over time. There's definitely some learning there, but on a per task basis, if it makes a mistake and then you refresh the context, there's literally no memory of that. This last one over here is a little bit more subtle. It's weird to describe our biological thinking as trusted, but you really only come to this fact when you juxtapose it with digital thinking, which is as an agent gets work done and it produces some output, it's clear that in many instances, like it makes mistakes, it cuts corners, it in some instances actually literally hallucinates things, right? And so digital thinking, I think, requires a level of verification that we're not necessarily used to when compared to biological thinking. We sort of inherently trust our own thoughts and our own train of thought because we at least have some like meta awareness of our own thinking and our own thinking tendencies. So when it comes to digital thinking, I think there's a new notion of verification that I think is really important to understand and get right, actually. And we'll talk more about that in a second. Okay, so what actually is an agent? I'm talking about digital thinking and digital brains. There's this really great framework proposed by Simon Williamson, who it's very, very straightforward. So given this input, and input can be some task that you give the agent or some question that you ask, but input is also sort of surrounding context that you also pack into your request. Given some input, the first thing that we do is we call an LLM, and then the LLM produces some outputs. But rather than the outputs just be raw text, the LLM can produce these things that we call tool calls. And tool calls, if you use ChatGPT, you see these all the time in the form of ChatGPT doing searches for you or going to websites for you. But in an agent world, these tool calls sort of naturally extend beyond that and can involve running actual programs on your computer, basically just using Bash or scripting or Python or whatever to accomplish really anything. And so what the LLM does is it actually generates these tool calls and it says, I want to do this search with these terms. I want to run this program with this particular invocation. I want to read this file into my context. And it basically just enumerates these tool calls. And then what do? We basically perform all of these tool calls out of band meaning outside of the LLM's purview. We're sort of performing the tool call. So we'll actually do the web search. We will run the command, etc. And then these tool calls produce tool call results. And then we take the tool call results, we put them back in the LLM context, and then we call the LLM again. We said, hey, you wanted to do these tool calls. Here's the tool call results. What do you want to do next? And so in turn, it might generate a new set of tool calls, and then we perform the tool calls again, and this loop basically continues until some arbitrary stopping condition. The stopping condition can be the LLM has decided for itself that it's fulfilled whatever input request, and then it's done. The stopping condition can be we as sort of orchestrators of this agentic system decide that we only want to allow 20 turns or 100 turns or whatever, right? Or maybe we have some out-of-band criteria to decide what done actually means. But the point is that this loop continues until some criteria is met. And that's it. Really, it's this simple. And this is literally all what an agent is. And so it's kind of surreal to describe this very, very simple structure and then make the argument that this structure is going to be the very thing that drives tremendous amounts of economic value over the next decade. And so let's explore this a little bit further. I believe in my own personal experience and sort of looking at the experience of many other people, there's this sort of arc of agentic usage over time. And I think it starts obviously with no LLM use. And this is where we all were just about 3 years ago, which is kind of crazy to think that all of this has happened in 3 years. It feels like a short amount of time, and so much has happened in terms of how we've changed our thinking on this topic. But you start off here, of course, and then most people start using an LLM. Usually it's ChatGPT, and they find ChatGPT to be really useful. And what they do is they spend a lot of their time basically copy and pasting context into ChatGPT or manually typing it out. And then when ChatGPT produces something, maybe it's like an email draft, maybe it's a document draft or a code snippet, you sort of copy that code snippet and put it in some other program. And so a lot of the value of ChatGPT is basically now bottlenecked on your ability to put context into it and pull context out of it. And so people realize that, hey, this is the bottleneck, and they sort of move on to the next phase, which is using something like Cursor. And here, Cursor is a code editor, and really what it does well is it gets the UX of calling ChatGPT essentially really, really great. So it reduces the friction associated with making the LLM call. So you don't have to actually spend time copy pasting stuff. It just makes it really easy. And then correspondingly on the other side, it takes the friction of taking stuff out of the LLM and putting it in your code, and it reduces that as well, right? But while I mentioned Cursor here, I think the notion of agent use is sort of general across all domains. And I think we should expect to see Cursor equivalents already starting to pop up and already starting to be used in all other parts of the company or the economy. And so in general, the idea here is that Cursor is the tool that we used to use to get work done. And what we've done is we've just created a more ergonomic way to use ChatGPT inside of the tool that we use every day. So this is phase 3. Now, phase 4 is interesting. I don't think that there's necessarily equivalence for 4 through step 8, which I'll get to. In other domains, I think software engineering is absolutely several steps ahead here. But Cursor agent is basically this notion of enabling this agent in the loop thing that we've been talking about on this slide, but within Cursor itself. And so you're still using this editor, but then the Cursor agent is taking actions now for you. Maybe it's running tests, maybe it's running searches, and so on and so forth. But really the way that you're using this is with the human in the loop. So you're still looking at the Cursor output, and then you're deciding whether to approve a command that Cursor runs or not. And you still, as the human, have the mental model about what you want, and you're sort of driving this thing, let's say. I think this naturally leads to a little bit more trust that people develop with the Cursor agent and the decisions that it's making around the commands that it's running and so on. And so people tend to run Cursor agent without approvals. And then I think this, people realize, I'll maybe speak in first person, I realize that hey, I'm leaning on Cursor agent so much that I'm not as much sort of looking at the editor, and instead I'm kind of primarily using like this sort of agentic loop and let it do stuff for me. And so I think a natural transition is into these terminal-based agents. And so you guys must have heard of Claude Code or OpenAI's Codex. These are agents that are sort of devoid or stripped of like the entire editor. And they still have the same functionality as like a ChatGPT thread where you can put context in, you can type it out, and so on and so forth. They have the same functionality as Cursor agent in the sense that you can attach files. But really they're meant to be used in a little bit more of an autonomous way, where they're able to execute a bunch of tasks. And if you need an editor where you want to like look at the code output, you sort of run that out of band. And so I'll spin up VS Code or Cursor to look at some diffs every now and then. But really, primarily, I'm sort of driving everything through the terminal. This leads to the realization of, hey, if I'm sending a task to a terminal agent and it's sort of getting work done, in some instances, this work can take several minutes all the way up to an hour in some cases. And so you don't want to just sit idle while this work is happening. And so people realize that you can run many of these things in parallel. In some instances in the same project, so that they might be editing the same exact files within the same project, which leads to some interesting coordination challenges, but also naturally on many other, like sort of separate projects in parallel. And this, I think, leads to the final step, which I would say is when you are running many of these agents in parallel, you kind of now take on the burden as a human of needing to check in on every single agent. And you may have noticed that these agents sort of get stuck at these almost like silly stopping points. So their stopping conditions perhaps are like a little bit too liberal, and they might ask for feedback, or they might say, hey, should I run the tests? Or, hey, should I like lint and format your code? Questions that are sort of obvious yeses. And you sort of realize that you can use an orchestrator agent to interface with your terminal agents and do this sort of checking and unblocking for you. And so The question that I have for you all is sort of see if you can identify for yourself like where you sort of sit in this like evolution. And my sort of soft nudge is, I think regardless of where you are, there's an opportunity to go even further, including at step 8. I think you can get more and more sophisticated with this orchestration. And so we'll talk about that in just a second over here. Okay, so I mentioned this notion that agents are stateless. And when it comes to this loop over here, designing this input is absolutely critical. And again, it's not just the specific tasks that you have at hand, it's the specific task paired with all of the context about who you are, what you want to see, like how you want the agent to behave, what tools do you want it to actually use, what are your standards for code quality and testing, and what general approach you want it to take. All of this information, I think, gets packaged into the input. And so input design is actually extremely, extremely important. And one of the key mental models that you have to have when you are thinking about this input design is this notion of context degradation. And so here's a simple graph. On the x-axis, you have the context window. And the context window is basically you're providing all of this input, the tool calls and the tool call results into this LLM chat thread, essentially. And as you take more and more turns around the loop, the amount of information in the context continues to grow naturally, right? And there's actually a finite limit based on the model that you're using. There might be 200,000 tokens, it might be 400,000 tokens. But what people are very clearly realizing is that regardless of what this sort of final limit happens to be, you get this degraded performance as you start to consume more and more of the actual token window. And so there's really a sweet spot, I would say. The right edge of the sweet spot is like a little bit ambiguous, but you really want the context to be as slim as possible. You want to avoid including information into this context that's irrelevant to the task at hand, right? And yet, you still want the agent to be able to find information related to whatever task you give it. And so it seems like a little bit of a paradox. How do we keep the context small while also giving all of the information for agents to get work done? And so with this in mind, people have discovered this notion of progressive disclosure. Progressive disclosure is a very simple idea. It's this idea that for the initial piece of context that we provide, in addition to the raw input, let's provide a high level, almost like table of content style piece of information in the form of this file called an agents.md file. When I say table of contents, it's this idea that I might give many different types of tasks to my agent, right? I might have it do a bunch of research. I might have it do a specific bug fix. I might have it actually check my emails. I might have it check production logs. And for each of these different types of tasks, in the agents.md file, I'll basically mention, hey, if you're working on code, actually check this other file in docs/codingstyleguide.md, right? Or if you're doing a web search, like this is how I prefer to actually do searching, and you can find out more information in this other doc. Or if you're looking at logs, like here's how our logs are structured, but if you want to find out more information, you can look it up in this other doc over here. And then finally, I think the third level is naturally the actual code itself. And so when you're like the actual detailed implementation of how all of our request handlers or backend services or front ends actually work, like that's obviously the most granular information. And so progressive disclosure is basically saying, rather than packing like the entire universe of information into the context up front, let's create these hierarchical structures where you only need like 2 or 3 levels, I would say, in order for you to basically represent all of the relevant information you might need to perform more or less any task. And so I think you really need to keep this context window degradation idea in the back of your mind, and then use that to really intentionally inform how you go about structuring your knowledge base. for all of the tasks that you want your agent to basically perform on your behalf. All right, this I think naturally leads to agentic search, and basically some context here. Probably about 2 years ago, maybe even like a year ago, a lot of people were really committed to this notion of retrieval augmented generation, or RAG for short. It's a fancy word for basically it's a solution for a problem, and the problem is I have some query, right? Some request. And I know that I have a bunch of information in some knowledge base. And so the question is, how do I actually retrieve the relevant information automatically and then put that into the agent context in order for the agent to actually answer a question? So for example, a support question comes in about one of our products, and then we have this large knowledge base of support documents, and we have a large knowledge base of support tickets. How do we actually find the relevant support tickets and the relevant support docs for the query that's actually coming in, right? So retrieval augmented generation, which is the old technique, is basically taking all of these documents and then chunking them up into little chunks, and then storing those chunks. And then when a request comes in, having some mechanism to basically find similar chunks to the request that actually just came in, right? So if this is like a DNS error that we're seeing in one of our products, right? How do we find all of the chunks that are related to DNS, right? And there's obviously very different mechanisms that you can do that. You can actually literally just search for the string DNS, or you can use this sort of vector semantic search, which we don't have to get into. But many people were sort of sold on this idea that retrieval augmented generation, vector databases, vector similarity search was going to be absolutely critical. Fast forward to about February of last year, Claude Code comes around, and what Claude Code basically, the team at Anthropic takes a view that it's actually really cumbersome to manage retrieval augmented generation, or RAG. You kind of have to figure out how to chunk your documents. You have to figure out how to vectorize the documents. You have to store these vectors in a database. You have to do the vector similarity search. The docs inevitably end up getting stale. Meaning as you update the docs, the actual stored vectors end up getting stale, and it just becomes this massive orchestration nightmare. And so what the Claude Code team said is, hey, when we as humans actually try to search for information in a knowledge base, how do we as humans actually go about doing that? Well, we oftentimes just do keyword search, like token search. Or what we might do is actually look at a README file, read the README file, understand what the README file is saying, and see if I can bounce around to the next file and then to the next document and so on and so forth. And they basically discovered that if we just simply give the agent the ability to use Bash, use the terminal, it can do this keyword search, it can read files, and it can do the same things that we as humans would do when we try to familiarize ourselves with a new code base. And so they sort of pushed us into this era of what we're calling agentic search, as opposed to RAG, where we just let the agents do the same things that humans do, and in that process sort of uncover dynamically the context necessary to solve any particular problem. And so as a result of doing this, they also realized, so you have to realize Anthropic is training models, right? And then they're also building Claude Code, right? So Claude Code is like the agent harness that does this loop that we've talked about, right? That we as consumers use, right? But then also the heart of the model, the LLM call itself, the LLM itself is its own sort of thing that they're producing, right? And they're sort of training, and they realize that if we want to sort of maximize performance on this agentic search, we can actually get the LLM itself to be more effective at agentic search. And so how do you do that? They basically said, what if we gave it some task, right? So some task is, let's say we have some code base and we know that this code base has a bug in it, and we know that we can sort of verify this bug in the form of a test, so that when you run the test fails, and that when the bug is solved and you run the test again, the test actually succeeds. So this is some environment, and the environment contains all of the code related to the project. The environment contains obviously like the terminal and the bash tool that I mentioned. So you can use tools like grep, you can use tools like, I don't know, CD or LS or whatever, all the tools that we use all the time in the terminal, right? And they basically said, let's now take 1,000 versions of this agent, right, which are all independent from each other, and then let's unleash these 1,000 agents to solve this task in parallel. And we'll sort of set it up in a way where each individual agent takes a slightly different path to solving the actual problem. And so they found that if you do this 1,000 times in parallel, that not all 1,000 of these agents actually succeed at fixing the bug. Maybe if it's a really difficult bug, a small subset, like 5%, actually end up successfully solving the bug, meaning 95% of them did all of these like tool calls, they traversed the code base, they ran some tests, they made some file edits and so on and so forth, and they ended up in an outcome that did not succeed, right? And so that's really interesting. They said if we're able to sort of bifurcate between the successful agents and the unsuccessful agents, then what we can do is we can train the model, meaning update the model weights, so it's more likely to generate tool calls and tokens like the successful agents and less likely to generate tool calls like the unsuccessful agents. So we're sort of nudging the LLM itself, like changing the weights so that it has more capability, meaning like it's more likely to traverse in trajectories that lead towards successful outcomes, right? And so you can do this for one sample environment, but then you can now scale this up dramatically, right? So I can synthetically generate challenges like code bases that have flaws, right? And then I can run 1,000 agents in parallel. And then I can just keep cranking this, right? And so I think what we've seen over the last, I would say at least 2 years, a lot, if not perhaps even most of the gains in capability that we've seen from these models have been derived from this process of what I'm describing here. So these challenges that are synthetically designed where I can have thousands of these agents try the challenges in parallel and identify the trajectories that actually end up succeeding, and then incentivizing the model to then do that more, right? And you just crank this wheel over and over and over and over again. And what happens is that the model develops this really, really nuanced and sophisticated capability to use these tools in what I would describe as like absolutely astounding ways. And so the invitation here is, how do we understand this RL derived, RL is reinforcement learning, and it's this process that I'm describing of these challenges and so on. So how do we understand the RL derived capabilities that are sort of emergent in these models? And then how do we align our tasks so that we're able to maximally benefit from the RL derived capabilities, right? So that's like an open-ended call to action, I would say. And I think one of the ways that we can do that is by actually writing CLI tools ourselves. And so I gave a talk maybe a year ago about agents, and I talked a lot about MCP. MCP is Model Context Protocol, again, developed by Anthropic. And it was a protocol where the Anthropic guys wanted to enable Claude to interact with our environments, right? So run programs and so on and so forth. And so they created this relatively heavyweight protocol, I would say, that's JSON-based, where if I want to give my agent the ability to search on Confluence, Confluence is our sort of wiki knowledge base, right? I would create like an MCP server and create an MCP tool that describes exactly what the input parameters are for the search call, and then exactly what the output parameters are, meaning as I do a search, like this is exactly the schema of the stuff that comes out, right? And people had some success with this. They were able to get their agents to actually do tool calls and integrate with these other systems. But then they very quickly realized that this does not really abide by this notion of progressive disclosure like at all, right? Meaning what you have to do is load up all of your MCP tools into the context up front. And in many instances, people realized that this was taking, I don't know, tens of thousands of tokens, up to 50,000 tokens. If your total limit is about 200,000 tokens, it's about like 25% of your context is just the configuration for your MCP tools, right? So in many instances, it's like a waste of absolutely critical context, right? And so people discovered, like, based on this notion of RL derived capabilities, like, hey, these agents are actually really good at using Bash, using the terminal, right? So why don't, instead of like creating an MCP tool, what if we just created a Bash tool, right? And so this is a tool that I actually use every day. It's a tool called SHOT. It stands for screenshotting, and it's like an agent-first tool for taking screenshots of an arbitrary web page. And so what it does is there's a headless Chrome browser that's running, that's wrapped in Playwright, which is like a UI testing framework, right? And there's this CLI tool here I've called the help page. And here you could say it kind of describes what the invocation is. So here's some options and the actual URL. The options include stuff like the output of where the screenshot should go, the width and the height. I really want to test like DPI. So I want to see how my projects look on like high density monitors versus low density monitors. So I added that functionality. And then I also added the ability to run an actual script when the page loads, so that you can do stuff like click around boxes. And then once the script completes, then it actually takes the screenshot, right? And so this is the actual like help page for the CLI tool. And you'll notice a few things. Like, firstly, you have all these like options, right? And then you'll also have a bunch of examples. So these are examples that are sort of the most common ways that I want my agents to actually use this thing, right? And all of this is packaged in like a simple CLI tool that I tell my agent to just reference, right? So instead of having this huge MCP thing, which consumes tens of thousands of tokens, now I just have this simple CLI tool. This is probably, I don't know, a few hundred tokens at most, right? And now all of a sudden I have my agent, I've given my agent the ability to take screenshots of any web page, right? Including like production web pages, or in this instance over here, actual like local development web pages. So in the context of Hall Pass, like actually taking screenshots of a real life running like local Hall Pass session is now trivial for this agent. Yeah, why don't we pause? Ben, you have a question?
Yeah, I was just, could you clarify, did you say, what did you say you fed into the agent in order to allow it to use this tool? Did you just feed it the help page or?
Yeah. It's a great question. I'm going to get to it in just a second. So for now, I've just discussed the tool itself. It exists. I can sort of manually tell the agent like, hey, use this tool to take a screenshot, which is one way of doing it, but there's a much more systematic way to do it, which I'll get to in just a second. It's a good question.
Thank you.
Okay, here's another example. So I found that in working on Hall Pass, I spent a lot of time going to GCP to look at our production logs and look at our staging logs and manually sort of comb through them to find like errors and things like that. And simply just like the friction associated with logging into GCP, clicking on the actual logs tab, trying to remember how to actually query logs, and then manually kind of going through the actual resulting logs and finding what I want and making sense of it. Like all of that friction was just so onerous that I decided to wrap all of it in a CLI tool called HP DevOps with this logs subcommand, and basically allows me to query the production logs or the staging logs. And it has some nice flags for like the time duration, filtering by severity. If I want to filter specific like student IDs or like pass IDs or things like that, I can do that. Basically like the most common ways that I want to query logs. I've now built that into this CLI tool, right? And here's some examples, right? If I want to see errors related to a specific pass, like it's this invocation. But then also here's like a really interesting one. This last one actually wraps on multiple lines. And you'll notice that we're trying to query prod with a limit of 20 with the string containing failed to parse JSON, right? And then what it does is it pipes it into JQ, right? because I have this output equals JSON thing, right? So instead of outputting text, now it's going to be outputting JSON. And then I can pipe that into JQ to then query subfields of the resulting thing, right? So in this case, it just wants to look at the message and the data, right? Now, this might not be useful as literally described, right? But what it's doing actually is when an agent runs this help page, it now sees that, oh, I can actually output this stuff in JSON and then pipe it into JQ. It's actually extremely extremely efficient and effective at using JQ. JQ is just like a command line tool for querying JSON. So if I have some input JSON and I want to filter it or I want to aggregate it or do anything to it, really, JQ is this tool that allows me to do that. And coming back to this notion of RL-derived capabilities, these models are extremely proficient at using JQ and then sort of chaining these commands to do more useful and efficient things. And so with this structure, this is literally like word for word something that I typed into one of my prompts. Use HP DevOps to find the top prod errors in the last 48 hours, cross-reference with the actual code, and give me higher level points of concern in the app and how we might fix it, right? And so it calls HP DevOps. It'll actually, it looked through like all of the logs in the last 48 hours. It did a bunch of calls. So it did some like error filters, some critical filters, and then it found some stack traces. And then it looked at the corresponding code relative to those stack traces. And then it gave me a nice package summary after about 40 turns in this agentic loop. And it said, hey, there's like 3 errors that I've discovered. One of them is actually like a real prod bug, like you should fix it, and here's what the fix is. One of them is actually just like a really noisy like log. You should just disable this noisy log, and here's how to do it, right? And the third fix was something else. I think you get the idea. But the whole point here is like this one string paired with this HP DevOps tool, right? Now all of a sudden gives me the ability to just have this higher level of intent and have this intent be fulfilled without me as the knowledge worker having to get into the plumbing of needing to pipe context into GCP, having to make sense of the GCP output, having to keep this mental model in my head, and so on and so forth. And then moreover, like it already, like after it's done, right? It has the context about the bug. And so it's just a matter of saying, okay, fix the bug, right? And then it'll just spin up a PR to fix the bug, right? And so for my own like personal like workflows and things like that, I now have half a dozen or more of these like manual custom CLIs that I have built that do everything from screenshots to logs, but also things like checking my email, or I have like a task management system for my own personal tasks for all of the different projects that I'm working on. Or I run like many of these agents now on my machines, and I run them inside of Docker containers. And so it's a little bit, it's like a lot of, like I want them to want my agents, I want to be able to systematically hop into Docker containers to do work. And so I built a CLI tool to manage all my Docker containers for me, and so on and so forth, right? So as I sort of build more and more of these CLI tools, they sort of exist on my system, and I'm sort of giving my agent system more and more capability over time. And this sort of effort like sort of naturally compounds, and it's absolutely phenomenal. Okay, so Ben, you asked this question, like how do I actually get the agent to use the screenshot tool? One version is you just ask it, right? Use the screenshot tool, right? But another version that's a little bit more systematic is this notion of skills, right? Skills are a standard framework that's now being standardized across really all of the agent harnesses. And basically, it again abides by this notion of progressive disclosure. And the idea is, I want to be able to give the agent more skills over time. And these skills might span many, many different domains. And for any given task, only a small subset of the skills might actually be relevant. So I don't want to consume too much of the context for unnecessary skills for the task at hand. So what I do is you structure your skills in literally a file called skill.md. There can be other files in this folder. And it has this thing called front matter. Basically, you provide a name and you provide a description. So this is the screenshot web pages skill. And the description is capture screenshots of web pages, use when you need to see what a web page looks like, verify UI changes, so on and so forth. And then the actual skill contents are given here. And all I say is, hey, just use the shot CLI tool and run shot help to see all of the options. And basically, what the agent harnesses do, whether you're using Claude Code or Codex or even Cursor, is they'll take all of the skills that you have loaded and they'll sort of put them in the input prompt for any new task, just the name and the description. And then they'll have some meta prompt that says, hey, for the task at hand, if you find that there's a skill in this sort of skill toolbox that you think is useful, what you should do is just read the whole skill file. That's all basically what the prompt says. And then as a result, now I don't even have to reference this shot tool, right? Whenever the agent sort of naturally discovers that it needs to take a screenshot for whatever task that I have given it, this skill basically guides it towards calling the shot help page, which then provides like all of the full details about how to use the shot tool most effectively, right? And so here, this skill is just for screenshotting, but skills are actually generalizable, right? So I have a skill, I mentioned like email, right? I have a CLI tool for accessing email, but then I also have a skill related to accessing email, right? So I have conventions around how my Gmail labels are set up, right? I have certain sort of desires. So when I want like some types of emails, I want to auto unsubscribe, right? Other types of emails I want to mark as important or whatever, right? So all of that is captured in the actual skill, right? And these skills we can sort of accumulate over time, and you sort of encode all of your ways of thinking or your edge cases and so on and so forth in these actual skills files. And we can actually share these skills files, right? So we can accumulate them on a per project basis. And as we all sort of use these agents and they work or they don't work, we can update the skills over time, and it sort of compounds. So with that, I'll pause. Vishal, you have a question?
Yeah, so talking about skills, now obviously you're talking more specifically around the development aspect, but we're also thinking about developing agents within our products itself, right? That could help customers with different things. And so have you experimented, Dwight, with either crew.ai or LangChain or LangGraph or other frameworks? Any color on, because I know Crew is very focused on the concept of skills and defining the task first, and that way thinking about the whole agent orchestration. What's been your experience?
Yeah, so I think there's two types of users. I think there's going to be like technical engineering users, and for technical engineering users, I would strongly encourage everybody to use something like Claude Code or Codex, because it's sort of closest to the sort of development environment, and in the process of actually using it, you realize that you can script these agents, meaning like write code that calls like agents, like the actual same agent harness that you would use in the terminal, right? Now for like other folks who are less technical, I think there's many like low code or no code solutions out there. I personally haven't spent any time in them, right? So I can't really say use this or don't use this. But what I can say is that this notion of skills specifically is generalizable across all contexts. It's just a really simple idea, right? There's nothing magical about it. It's just, let me provide the minimum set of information that describes what this skill is and when it's relevant and when you should use it. And then the skill body itself will hide away, so it's not loaded into every single request, right? And that way you get this like nice progressive disclosure, right? So it's just like a convention for how we might do progressive disclosure.
Sure.
Ben.
Yeah, I had another question, but I actually have a better question. So I love this idea that these agents are all sort of running in parallel and orchestrating with each other. Are we at all worried about the cost of running, tens or hundreds of agents simultaneously per person? Like, are we worried about the eventuality where the companies that we are paying for their agents start charging us more money, and then we'll have to alter the way that we get our work done, or we just
Yeah,
set a feature as problem?
it's a good question. So I have a few thoughts here. I'll maybe ask Rich this question too. But my high level thought is, when you use these agents, ideally you're using them in a way that is valuable, right? So coming back to this GCP logs thing, right? Like I could have manually went in and did log triage for the last 48 hours, right? But the cost to the company, right, would have been the hours that I spent actually doing that, right? And on a per hour basis, my costs versus like the actual agent costs are probably 3, maybe 4 orders of magnitude different, right? And so I would argue that as long as we're using agents to do valuable work, right, and it's like sort of obvious what value means, I think, in this context, then I think we should seek to really crank up token usage, token consumption to the absolute maximum. Now, obviously, I caveat that with like, don't just burn a bunch of tokens doing useless work. But obviously, that's not what people are arguing for over here. Like I just think already today in 2025, like the efficiency of agents on a dollar basis it's just so much better than having humans do the equivalent task, that cost is not like an absolute concern for me.
And Advite, if I might add, and I just put a little note in the chat as well, which essentially says the same thing you said. My only add would be, it's a great question, and it would almost be nice if folks are pushing it and then we're asking ourselves that question, right? So I know this sounds like a strange answer, but if the bill keeps going up to a point we're getting a little uncomfortable, it will force us to say, is this a good thing? And I think, again, implicit in Advite's answer is we think over time this is a good thing because the ROI really is there. So I love the question, and I'd say, you know, it's sort of a positive if we get ourselves a little uncomfortable in the amount of usage we're starting to drive.
All right, you heard it here first. Whoever has $1 million AWS or OpenAI bill wins.
Advite, you mentioned 3 to 4 times order of magnitude. That's just based on your usage or an estimate, or
no? It's super hand wavy, right? That's just my intuition about this. I would say I would describe it in terms of like I have a 1-year-old kid at home. I have like a finite amount of time that I can spend in the day, right, on anything, right? And so that time is extremely, extremely valuable to me. And so if I can avoid doing plumbing work and have agents do plumbing work on my behalf and instead focus on the intent level, right? That trade-off to me feels like a 3 or 4 order of magnitude trade-off. And for me personally, like I'm racking up $1,000 or $10,000 like monthly or annual like token bills. But for me, like that trade-off is worth it because I'm seeing the value on the other end as like worth way more than the sort of upfront cost that I'm actually paying.
And Advite, I'm over my skis in this comment, but obviously Hall Pass was a product that in part was built using some of these new tools, and it was a product built extremely quickly. It's going to market obviously just in a few days. We got several $1 million against it. So that might be kind of our first use case of something was built faster, it got to market faster, and then the ROI comes obviously in that we're going to get the revenue from that ahead of the time we normally would have done.
Yeah, absolutely. Mariana.
Advite, this is really eye-opening and really valuable to see. I'm curious, you talked a lot about the application of this progressive disclosure framework to agent skills being deployed for specifically in an engineering context. But I'm sure we can all imagine that there are a number of tasks that roles across the organization would benefit from having custom agent skills for the tasks that they need to take. What are the core competencies that you think about are necessary for being able to design and implement agent skills in contexts that are not necessarily engineering, let's say sales, marketing, or all of these other types of roles in the organization?
Great question. So it turns out that there's a skill creator skill, a meta skill for creating skills, right? Which you can load up into your own agent, right? And it'll actually handhold you through this, and it'll ask you questions and get all of the context that is needed in order to create a skill, right? It's skills all the way down. I think these skills are absolutely generalizable beyond engineering. So let's just like brainstorm some examples here, right? We should have a skill for after we have like a sales or support call with a customer, We want to review that call and see like what the action items were, whether we actually presented our products in the correct way, what the customer sentiment was, or if a support ticket comes in, we want a skill to be able to triage that ticket. If we want to produce a piece of marketing collateral, we want a skill that describes our brand voice and the actual colors that we use, or the tools that we use for the content management system, and so on and so forth. Literally anything that facts or principles that you have as a knowledge worker, the invitation is to encode those in the form of these skills so that agents can then use those skills and do work on your behalf in the ways that you would do the work. That's the idea.
Yeah. And I think, Mariana, also just building on what Dwight said, you also have frameworks, both obviously Claude is there, but you also have other open source frameworks as well, right? Like Cron AI, it's actually very focused on replicating the human behavior. So the whole idea there is to define the task and then define the skills. That way, which agent can work on which task. It's almost replicating the real world thing. And you could have autonomous agents with human in the loop, with reinforcement learning, all of those things. But this area is progressing very, very fast.
So I want to be conscious of time here. There's actually some really, really interesting stuff I want to get to. So I won't stop at the hour, but I know some people are going to have to drop off. So we'll keep going, but I want to get to this before the hour. So the first thought here is I believe that this kind of parallelization that agents are enabling, or the ability for them to do plumbing work for us, is like on a like human civilizational time scale, is like one of the like largest like turning points we've ever seen, and you can even juxtapose it with some historical crazy ones. So you look at the printing press, you have one writer, and now all of a sudden they can have millions of readers. Or if you look at the assembly line, you have one design, now I can have millions of units in this design. With software, you have one program, you can more or less have infinite copies of that program. And now I think with agents, you can have one intent, and you can basically have scaled execution of that intent that can be like scaled, parallelized, however you want to put it. And I think it's absolutely at the same level of these other sort of foundational things that literally change the trajectory of human civilization. I think that's what's happening over here. Okay, so event-driven and cron. This is I think really cool. Perhaps like the most interesting part of the talk, in my opinion. So so far we've talked about using agents in this sort of human-driven way. So you have some human intent, you express that intent, and then it's able to do a bunch of work, right? It turns out that you can use agents in an event-driven way, or cron. Cron is like a way where we can run tasks automatically and repeatedly on some interval, right? And so here's some examples of how I'm using event-driven and cron structures. So every 30 minutes, I have a cron set up. So it's just like a job that runs, which checks my email. For every email that comes in, it does the triage using my email triage skills. I've got a task management like CLI tool that I mentioned. So it'll create new tasks for me. And then if something is truly urgent, it'll actually proactively send me a message. And now I literally don't check my email anymore, right? I have everything funneled through this system. Every 10 minutes or so, I have a cron that I've got probably 6 different projects that I happen to be working on in many, many different contexts, inside of GoGuardian, outside of GoGuardian, and so on. And so oftentimes you have these cursor agents or these Claude Code agents, and they're getting work done, but they get stuck, like I mentioned, right? So I literally just have a script that runs, and again, it's an agent itself. And what it does is it looks at each of the Claude Code instances or the Codex instances, and I have a skill that describes, hey, if this thing is like trivially blocked, meaning it's asking for input where the answer is obvious, then simply just unblock it and ask it to continue, right? And then if it's actually like blocked on something where a decision is needed, then figure out the context associated with that decision and frame it up to me, right? So now, instead of me having to kind of live within the individual Codex instances for each of my projects and manually having to babysit them, I now have this layer on top, which is proactively checking all of my agents for me, and then sort of sending me push notifications on, hey, this agent over here is stuck. It needs this input from you. Like, what do you want to do over here, right? And so I'm finding that like now I can kick off these background tasks, like these agents, and then have them sort of reliably make progress without them getting stuck in these like silly stopping points over here. This one is actually really nice. So every morning at 6 a.m., I ask it to give me a briefing on all of my projects, all of my open tasks, and propose how to approach my day based on like the calendar events that I have. So some days I have like extended flow blocks where I can get like really deep work done. Other days there's lots of meetings, and based on the nature of those days, right, I just ask it to give me like a straw man proposal for how to approach my day, right? So now I don't have to be in the business anymore of managing like my own schedule, managing my own task list, managing the mental model of all of the various commitments that I made and so on and so forth. Instead, I just get framed up like a full summary of exactly how I should approach my day. And it's not like I'm following it blindly, right? But it gives me all of this context, which I would have ordinarily had to manually accumulate, or worse, just sort of forget because it's sort of the natural tendency that I have to just like forget stuff, you know? So I no longer have this like paralyzed feeling or of needing to like manage all of my tasks. I can just have the system kind of do task management for me, and I can just do tasks now. And so this thing scales, right? So think about all of the opportunities we can use sort of event-driven agents in GoGuardian, outside of GoGuardian. So I talked about this logs thing, right? Like we should have agents that are proactively looking at our prod logs all the time and sending us like errors, but not just sending us errors. They should cross-check them with Jira, cross-check them with our code base, and only create new tickets if new tickets need to be created, and then sending us proactive messages if something is actually like urgent, right? I already mentioned sales calls, right? Like literally every single event that comes in, whether it's a customer email or a sales call that actually happens, or literally anything, like an agent should be running like on the back end of that to process what's happened, reorganize it, recontextualize it, escalate it, and so on and so forth, right? So we should have many of these agents running on this event basis. I would argue perhaps more agents should be running in this way, as opposed to in the way where humans are sort of specifying the intent manually, which is sort of the default state. So agents should be able to do work without human prompting. Agents as a glue layer, I think this is sort of self-evident, right? In all these examples that I've described, agents are going through multiple systems, whether it's code or logs or whatever, right? Stitching together information and then giving me the sort of higher level summary, right? So before, as knowledge workers, we were sort of responsible for being the glue people for needing to stitch together all of these tools. And now I think we should be leaning on agents to actually perform the glue function, because the actual glue function is not valuable at all, right? It's like there's no decision making involved, there's no judgment involved. It's literally taking information from one thing or calling this other thing and then consolidating all of that. And then from the consolidated like summary, then there's actually intent. Then there's actually a decision to be made, right? And so that I would argue is the value as knowledge workers that we're actually providing. And we should be leaning on these agents to do the gluing on our behalf. And then I know we're at time here. Feel free to drop off if you have to. This is a recorded call, but I do want to talk about, this is not all fun and games. I've talked about all of the positives. I want to talk a little bit about the challenges here too. First challenge is lots and lots of iteration is required over here, right? So in order for me to build this sort of email task management system, for example, I had to spend an enormous amount of time getting all of my intent, getting all of my like ways of thinking about tasks, building these CLI tools and so on and so forth, captured in the form of these skill files, right? And then I'll sort of run these workflows and see that they don't work, right? Or break in sort of silly ways, right? And so I'll have to take another iteration to refine the knowledge base and so on and so forth. And in my experience, this is sort of a endless project. I don't think I'll ever reach a point where the sort of agent system is done. it's sort of continually evolving as I use it more and find that it's deficient in some ways and seek to address those deficiencies. And so the sort of axes where I'm iterating is on the left here, like actually capturing knowledge, right? In the middle here, it's actually capturing skills themselves and iterating on those skills. And then finally, like iterating on the actual CLI tools to give it functionality to integrate with more systems and so on. Here, like, despite how we might scale up agents, like Ben, you mentioned like hundreds of agents. Like I haven't gotten to hundreds of agents. Like the maximum number of agents that I've ran in parallel is maybe like 5, 6, 7, right? And the reason for that is like there's still human judgment required. These agents are not perfect. They make mistakes. They do silly things. They cut corners. They introduce bugs, and so on and so forth, right? And so there still needs to be a core part of my attention that's devoted to each agent, what it's doing, and having a mental model of how it's approaching a task, and then sort of figuring out how to nudge it in the right direction. And so this sort of human attention piece still absolutely is the primary bottleneck for the work that's getting done in my sort of personal agent system. That said, I'm spending less and less time doing the glue work and the plumbing work, right? So it's still a much better situation than before, but there's still this critical bottleneck. And fundamentally, like regardless of how much we scale up these agentic systems, like this notion of like the human intent and expressing the human intent, I think will always be like a sort of primary like gating factor to the sort of scale and impact of the underlying agent system. Ben, go ahead.
Yeah, I think that's a really good point, and it's something that I've experienced too. Although I haven't used the CLI tools, just even in using Cursor, I find that it's tremendously useful for producing code very quickly and with good intent. However, I'm still spending a fair amount of time, I guess, verifying that what it's done is what
Absolutely.
I want it to do. And I'm wondering if you've encountered any or come up with any mechanisms to increase the speed with which you can evaluate whether you're happy with what the agents have done. Or is that still the classic, you know, I don't know, if I don't see it for myself, I don't believe that it's working, or if the unit tests don't pass, I don't merge the code, you know, like.
Yeah. So good question. I think first I skipped over this slide. There's this like idea that's starting to emerge in the community. It's this idea that there's this thing called verifiers law. And verifiers law basically says that any easily verifiable task will eventually be conquered by AI. Like, what does this mean? Easily verifiable basically means that if I have some task output, can I very quickly and easily judge whether that output is good, right? Whether it's code, so in a code context, this might be tests that run and sort of verify that the program works as intended. It might be a linter that runs, but it extends beyond that, right? Like I mentioned the screenshotting tool. Like I have some verification steps around clicking around the actual apps that I'm building and verifying that the UI is working as intended. In some instances, I've even had like stylistic verification. So I ask it to load up screenshots of new UI that it's built out and like stylistically judge, like, hey, is this like good? Like all of these images were actually generated by AI, like agents specifically, where I asked it to be sort of consistent from like a color and background and line art style perspective, right? So there's some verification step there. So verification, basically what people are saying is that if you can verify well and easily, and you can express your human intent in this verification, then that is basically a sufficient prerequisite for AI to just fundamentally like solve your task. Because what it enables is the AI to try like infinite permutations of how to approach the task. And because the sort of cost of trying these very many permutations is so low, as long as I can verify that some subset of these like permutations actually ended up working, like then you'll eventually converge towards something that works well. So I think verification and getting the verification right is like a super, super high leveraged idea. Another thing that I'll mention is for many tasks, I spend an inordinate amount of time with the agent up front, sort of manually gathering context about the task at hand. So let's say like recently I was working on some like authentication related change inside of Hall Pass, and it's like very complicated. It touches like multiple tables in Liminex Ent. It touches multiple upstream services, and it makes like a major like foundational change to how we authenticate users and verify their roles. And so there's like no tolerance for getting something wrong over here or introducing a bug, right? So what I do is I spend a ton of time myself with the agent around understanding myself, like how the actual code works. So how are the actual tables in the upstream Liminex Ent structured? How are they actually written to? How are these sort of intermediate services reading those tables? And then how is Hall Pass actually consuming those intermediate services? And then how is the logic for authentication actually working today? And I ask it to basically explain this to me so that I also have a mental model of how everything works today. And then I brainstorm like what the actual solution should look like. So which code changes should be made without actually making the code changes, is simply enumerating like which files are we changing and what logic should we expect. And then in this particular case, I actually wrote the tests. Obviously, I had the agent write the tests on my behalf, but I actually enumerated the test cases that I wanted for the verification here. So like this particular user, I expect to have this role in this instance, or in this other instance, I expect this other role to actually be resolved, right? So I enumerated all of these like test cases. I had the agent write the tests, and I was expecting actually that because this was such a complicated problem, that it would take the agent, I don't know, tens of minutes in order for it to actually succeed over here. And that's why I was like really deliberate about enumerating all the upfront context and enumerating the verification in the form of these tests. But what I discovered is that because I spent so much time doing all of this pre-work, when I actually asked it to perform the task, the final solution it was able to come up with within literally like 35 seconds. And it ran the test, and the test passed, and then the process was basically done. And I was extremely confident based on the actual tests that were written that the final code change was actually legitimate. And so the broader point that I'm trying to make here is that for these like really detailed, complex tasks which require nuance, which have a high level of risk associated with them, it helps to sort of manually walk through the agent through your own thought process and your own investigation around how everything works together. So you have this mutual mental model in your mind and in the agent's mind, shared really, and then spend a lot of time on this verification step. And I think the combination of both of these actually enables it to be extremely, extremely effective at getting the final task done. Yeah, back to you, Ben.
That's super interesting. I'm wondering, so two questions. One, do you have an agent or some sort of specification that you've written that helps you go through that process, and that you've told the agent in advance that that's the workflow that you want to go through? And second question is, as you're going through that, where are you storing like the learned context of all of the work that you've done so far? So is that something that your agent is generating like a file that it's keeping track of the work that's gone through so far, or is that something that's all held in the context and it just happens to be small enough? Like, how do you make sure it doesn't forget?
Great questions. So on the first point, it really depends on the task at hand, right? So some tasks for Hall Pass, for example, are just like simple UI changes, don't require really any context besides like the surface level React component, right? And so you can just like literally one-shot those, like those are non-controversial. But these other tasks that I'm talking about are much, much more heavyweight and require like much deeper research and so on, right? So I don't have like a research automation task. Instead, what I have is my own intuition around which services to consult and which schemas to consult and which tools to consult and so on and so forth. Basically the things that I would do if I were to do the task manually, and I'm just having the agent sort of fulfill the glue work and the plumbing work to do it on my behalf, right? And I'm finding that like that process of it just sort of facilitating the research in ways that I would drive the research is actually really, really effective. Now, to your point, like I might actually take the conclusion here and codify that in the form of like this docs file. So instead of docs / like authentication.md, it might actually be super valuable to take those learnings and put them in this file, right? But in my experience for this particular task, like it was not really necessary to put it in doc form, right? Instead, I just kept it in memory in the context itself, and the agent was able to fulfill it. Now, for other tasks, I do notice that it's actually really useful to get a lot of this like research results down in the form of written documents, and then actually hand off those documents to a new session. So what I'll do is write the docs, and then I'll start a brand new session with a fresh context. And the first thing that I'll do is have the agent load up the docs that the previous agent wrote, and then I'll sort of continue from that point. And I think that pattern is really useful when the initial research process ends up consuming a lot of that like critical context window. Just sort of getting everything down in doc form is actually really, really effective. And so the maybe broader point is like, there's not really a one size simple solution over here. I think the invitation is to actually try these tools firsthand and develop your own mental model of how these tools work, when they work well, when you can sort of one-shot tasks versus when you have to really handhold a task, handhold research, and so on and so forth, like I've described, right? Okay, so continuing onwards. Just some final thoughts here before we can turn it back to you guys for open-ended questions. I talked about lots of iteration required, human attention being the bottleneck. I want to talk about security and risk because I think this is a real thing. Prompt injection is this idea that when I ask, for example, an agent to read a document that I have not written, that I don't necessarily fundamentally trust, maybe it's an email that came in that I didn't control, right? That email can actually be constructed in a nefarious way so as to trick the agent into thinking that maybe like the first part of the email is like the actual email body, but then there's some fake trailer in the email that convinces the agent that the email has actually ended, and what follows is actually like authoritative instructions from me to do something else, do something nefarious, right? And that might be like taking my private keys and exfiltrating them, or it might be taking like sensitive files or information or exfiltrating those, or it might be using the elevated permissions that the agent has to do something bad. And so this is like absolutely a real thing. Basically, all of the frontier AI labs, literally all of them, have acknowledged that prompt injection is a like a real thing that is like demonstrated in all of the models, whether it's the most powerful models or the smaller models. And it's actually not that difficult to construct these nefarious prompts. And so like the question at hand here is like, what do we do about this thing? Because on one hand, you have all of the capabilities that these agents and these agentic systems have in all of the ways that I've described, but then juxtaposed with like there's like clear data exfiltration risk or clear like privilege escalation risk, right? And so what do we do about this? I think my response personally is there's not really like a one size fits all solution to this. Instead, I think we need to look at the task at hand or the context of where we're deploying these systems and simply understand what the risk reward trade-off is. And at the same time, try as much as possible to sort of contain the boundaries of the actual like what could go wrong in a sort of maximum extent. So in my practice, like what I do is for every project, I run all of these agents inside of Docker containers that don't have access to my home directory or anything like that. And moreover, I'm running all of these agents not on my personal computer, on my personal laptop or my work laptop. I'm running them in a remote environment on a virtual machine that doesn't have access to any of my personal information, right? So that's like one level of bulkheading, I guess you could say. So each agent is running in its own container that is in itself isolated. So there's no sort of cross-project concern. So for example, if an agent accidentally runs a command to remove its home directory, which has happened in the wild for people out there, that will be confined to the Docker container and it won't be sort of catastrophic. Now that said, to the extent that project files exist within that container and that container has internet access and is running like these bash tool calls, there's absolutely data exfiltration risk. And so again, I think we have to figure out like, what do we do about this? And I sort of leave it up to us together collectively to figure out like rational policies around how we might manage the risk reward trade-offs over here. But this is absolutely a real thing. I don't want to pretend that this is like a solved problem or not a problem at all. Instead, I think we need to consider the problem at the same level as the value and figure out the right trade-offs together. Okay, in terms of next steps, if you haven't already, install Claude Code or install Codex. I think either agent is good. And try to do a full task through the actual agent. So if it's a PR, try to do the entire PR in the agent itself, including like the actual terminal commands, including the actual git commit and the actual git push, including the actual PR like code review, like the diff review. Try as much as possible to kind of do it within the CLI agent. And initially it's going to be like pretty cumbersome. You're going to have this desire to want to open a new terminal tab and manually run a test or manually git commit or branch or whatever, right? But as you sort of push yourself to do more and more through Claude Code or Codex, you realize that it's actually really proficient if you provide the right level of intent and provide the right level of agents MD or docs or whatever. And over time, you'll build more and more trust and autonomy for this thing to do tasks on your behalf more at scale. And so with that, I'll open it up to more open-ended questions. Let's go.